This is the third video in this series. We're now going to look at graphs of functions. Let's take an example and look at a graph of a function. I'm going to have my x-axis. I'm going to have my f of x, which is my y-axis, my output axis. Remember that the domain represents all of your horizontal values going from left to right. And then your range represents all of your vertical values. So if I decide to make a single point and decide, is this a function? And the answer would be yes, because I come over here. This represents the value of my input. It's along this x-axis. Now this maps to this point here, and this point on the x-axis here, we'll call it f of a, and we'll call this a, because a just represents a number. And so this would be a graph of a function. Not a very interesting one, but still a function nevertheless. Let's add another point. Let's call it point B. And now that maps to f of b. And we actually have the coordinate point now, b, f of b. Now this is a function as well. For this input, I have one corresponding output. In fact, I could string a whole bunch of points together and I would still make a function. In fact, I could also connect all the dots. And if I look at, maybe this is my proposed function here, and it's this line. Let's select any point that I have along here. Let's do this. I'm going to pick C. I'm going to map it down that. That has one solitary output. That's going to be f of C. So yes, this is going to be a function. Now, let's look at something that's not a function. Let's say I have something that looks like this. This is a sideways parabola. But let's pick this point right here. Let's call it D. Now, this point maps to either this point here or this point here. And because it maps to 2 points, this is not a function. Okay? Doesn't matter what's going on over here. That has no bearing on whether it's a function or not. As soon as you find any point maps to 2 points, then it's not a function. Let's say I had this squiggly line here, and I wanted to decide, is this a function? We can see that we can pick any point along this axis and map it to a point here on the graph. So I can pick this, maps to that, this maps to that, this maps to that. That's all fine and good. As soon as I make any other point that's not on this line, let's say I have that and I add that to my line here, then this is no longer a function. So because of this point right here, this will not be a function. Now sometimes we can get away with removable or holes in our graph. And let's say I have this line here, I've got a hole here, means that the graph goes all the way up to, but doesn't include this number. It's infinitely close to that. And it also comes all the way up to this number, but it's infinitely close to that. This is a function all day long. Now, because this doesn't have a value, that doesn't make a difference. This is still a function. If I draw a dot up here, we still have that input-output correspondence. So if I have my input, let's call this E, that maps to this point right here. So even though I remove that point and put it somewhere else, as long as it's vertical from it, then it is a function. We have something called the vertical line test. And the vertical line test is just a way of taking a vertical line and you drag it across your graph. And if that vertical line crosses your function at 2 or more points, then it's not a function. So if I drew something like this, we know immediately not a function. If I drew something like this, this is a function because for every vertical line, it only crosses the graph at one point. Let's say I had something like this. This was not a function. We hit 3 points there, okay? Let's say we had something like this, where we had a circle to a solid, circle to a solid, circle to a solid. If we look carefully, and let's just assume I did a pretty good job doing this, this passes our vertical line test, because where we have this circle here, we have a dot, but that's okay. It only hits one single point going across the entire graph.